Jai Hind everyone, myself Ankita, Faculty Department of IT, AKGEC. Today I am going to discuss the important topics of Unit 4 of the course BCS 601 Software Engineering. So during the last classes we have discussed about various steps of software development lifecycle model. We started with requirement engineering and specification, in which we collect the requirements for a software and analyze those requirements and form an SRS. After that, we do design, right? Now, after designing the software, we do actual implementation. And after we are done with implementation, we go to the next step, that is testing, which we are going to discuss in this slides. So the various topics that we are going to discuss is first is introduction to testing. Now, various levels of testing, that is the unit testings, integration testing, system testing, acceptance, alpha and beta testing. Then we will study different types of testing, that is functional testing and structural testing, and what are stubs and drivers, and the last we will study the approaches of different software testing. Now basically, what is software testing? It's a process of testing the software. So why we need to test the software? It's a very simple question, and the answer is also very simple, that we need to check that what the efficacy of the end product that we have created. So we have to see whether all the requirements that we have decided before making that product is being met by the end product or not. So that is the main aim. We have to check the software does not have any errors and it is according to the expectations of the user. So mainly we are just testing to find out that whatever end product that we have made at the end of SDLC cycle, that end product conforms to the requirements that has been set by the customers. So basically, effective software, how should we test the software? Now, testing is important, that we have understood, but how should we test that software? Now, that process should be methodical, right? There should not be randomly, we should not test. It should be methodical so that we are able to cover every aspect of the software requirements. Now, obviously, if we are doing the software, testing the software effectively, we will be having high quality software product. It means it will be having highest quality, it will be meeting the requirements that has been set by the users. Also, explicit requirement that has been set by the users, as well as implicit requirement that is required by a professionally created software. Also, as a result, if my end product is of high quality, my customers will be more satisfied. The maintenance cost will be less. Obviously, if my software is high quality, maintenance cost will be less. So obviously, we can say that testing is a very important process in which we are testing our product and we are ensuring that quality of the software product is maintained. It is also an expensive process because it consumes nearly 1/3 of the cost of the typical development project. So if we are saying that we have to test, it requires a lot of time to test it effectively. So it is therefore we can call it as expensive process. Why? Because it requires enough time to get it tested. It is partly intuitive but largely systematically. So we have to use intuition as well as systematic approaches so that we can test the software effectively. So basically, in this slide, we have understood what is software testing needs. Now, when we go to, for the definition is the testing is the process of executing a program with the intent of finding errors. Now, this is very important. So, when we are trying to test the software, our goal should not be to establish that yes, my software is conforming to the requirements, but our goal should be finding out more and more errors. So a good software tester is one who is able to find more errors from the software, because the more errors we will be able to find, the more quality, the more future problems will be discovered beforehand only, and we will be able to rectify those problems. So the main software testing aim of software testing should be we have to find more and more errors. Now, when we are testing, we have to follow an approach. So, we have formed a hierarchy of testing. Unit testing, integration testing, system testing, at the end it is acceptance testing. So, what is basically unit testing? Now, when the software has been implemented, it is implemented by the developers. Now, all the software is implemented in different modules, or we can say different units. So each of the those modules should be tested independently, and that is done by only developers. So each developer who is developing a software unit will have a responsibility to test that unit. So that is known as unit testing. It's basically a part of your implementation only. So when the software developers are developing a software, they are developing it in units, in modules, and when they are running those modules independently and testing them, we call it as unit testing. So what is a unit? A unit is a single testable part of the software system which can be independently tested during the development phase, right? So obviously the purpose is to test the correctness of the isolated code. A unit component is an individual function or core of the application. So that a piece of code that can be tested independently has to be tested beforehand, so that we can know, yes, the our module is working according to our requirement. Next is your integration testing. So when we have all our tested units, so we have various units, and these units has been independently tested by the developers after the production. Now we need to integrate these units. These units needs to get integrated with each other. Now when they are getting integrated, we need to conduct integration testing, right? So the focus of integration testing is to expose defect at the time of interaction between the integrated components or units. Suppose this is my attendance and this is my marks. So if these two modules have been checked independently, now we have to check whether when we are marking the student, we are getting the attendance data correctly or not. So this type of testing we do in the integration testing, right? So here the software is developed by a number of software modules that is coded by different coders. Now the goal of integration testing is to check whether the communication between these two modules are happening correctly or not. So these are my different modules and how they are integrating with each other, how they are communicating. This communication should be correct. Next is your system testing. Now in system testing, what we need to do is we have to check that our whole system has been integrated now. Now we have to check whether my software is able to work perfectly fine as a fully integrated software system. When I am deploying my software on a particular hardware, whether my software is working properly or not. So in other words, we can say system testing is a series of different type of tests with the purpose to exercise and examine full working of the requirements. So we have our requirements with us and we are checking whether our software is working according to the requirements or not in entirety. So here we are checking the software as a unit, right? So against the requirements we are checking. So this is called as system testing. Now we are checking the individual modules. This is done by the developers. We call it as unit testing. Then we start integrating those modules and doing integration testing, which is done by the testers. And after the full integration of the software, we are checking the system in totality against the requirements, and we call it as a system testing. Now after system testing is done, now this is done by the developer end. Now next type of testing is acceptance testing. It is done by the user or the customer. So before accepting the software, the user will confirm whether the requirements that we have stated in the beginning of the project is being met by the software product or not. So that is known as your acceptance testing. It evaluates the compliance of the system to the business requirements, and this is done by your users, or you can say customers, right? So these tests are conducted by end user or customer and may range from simple tests to a planned systematic series of tests, and it may be conducted for a few weeks or months. So that is your acceptance testing. Now suppose this is a product which we have some requirements given by the customers, and we are creating that product, we are creating that application, and then we are giving that application to the user to check, right? Now what if we have a software product right? For example, I have an e-commerce website. I want to test it. I have made my game. I don't have any customer for it, right? I have myself as a developer. I have myself, formulated a problem for myself, and then I have solved that problem through a software product. Now, who is going to check that software product for me? For example, I have created a game. Now, I have some notion in mind, and I have created some game, and I want that game should be tested. So, according to me, the game is working fine. So, how will I test that game is working fine for the other actual users or not? For that, we do alpha and beta testing. Now, alpha testing is done at the developer side by the customer. The customer could be any customer. We can select a sample population and we just can, conduct the test. So, alpha test is basically conducted at the developer side, and these tests are conducted in controlled environment. Controlled environment means that our hardware will be ours, our operating system will be ours, and our software will be ours. But the testers are some other people who are not concerned with our organization, right? So that is called as your alpha testing. Whereas the beta testing is done by the customer at their own site. So you have all, enjoyed the beta version of various games, right? So these are all beta versions in which the general public tests the software at their own systems and report any errors or report any improvement they want in the software to the team, right? So that is the difference between alpha testing and the beta testing. So in contrast, we have acceptance testing. Now, acceptance testing is done when we have our customers defined and they are giving us some requirements and we are fulfilling those requirements, and then at the end the customer is checking whether the requirements isn't fulfilled or not, right? So in such cases we do acceptance testing. But when we don't have any customers, we have developed a product on our own and we want the acceptance of the users, what do? We give them a free copy of the software and we ask them to check. So if they are testing the software in our environment, in our premises, we call it as alpha testing. If they are testing it in their own environment or in their own premises, we call it as beta testing. So that is alpha and beta testing. So we have till now understood unit testing, then integration testing, system testing, and then the users do two types of testing, that is acceptance testing and the alpha and beta testing. Now we have understood what all we do in your testing. Now, before proceeding further, when we are saying that we are testing the software, what process, how do we test the process? So we made some test cases. Test cases is what is basically have the purpose, precondition, inputs, expected outputs, post condition. So this is a test case, a sample test case that we prepare before testing. So here we write out the purpose that we are testing, that is which module we are going to test and what we are going to test in that module. Then what is the precondition for executing that module? What are the inputs that we are going to give and what is the corresponding output that we will expect. After that, we will who has run that, and this is all that we do. So this is actually your test case. So, and one test case is known as a test and a collection of test cases is known as test suite. So this is how we test. Now basically when we test, we categorize into two forms. One is your functional testing and other is your structural testing. Functional testing is also known as black box testing, in which we are considering the software or a software product as a black box. We are not we do not consider any you can say any functionality in it. We just say this is my input and this is the output we should get. So this functional testing checks the functional requirements of the software and it tries to find out that the requirements are being met or not. It is also known as black box testing and it focuses on what the system does, right? So it can be done manually as well as by automation tools. Now how do we do the functional testing? First is we identify the test data, that what should be my input, and then we find out corresponding to what my should be input, I have my expected output, and then I execute the test case, and finally I compare the actual output with the expected output. So if the actual output matches with the expected output, it means my test case has successfully done. Otherwise, we report an error and that error is sent to the developing team who rectify that error. Now, various types of functional testing are, first is boundary value analysis, equivalence class testing, decision table and cause effect. The various variants of boundary values are robustness and worst case testing. So, what is boundary value analysis? Now, it have a notion that all major errors occur at the boundaries of the input domain. Okay, at the boundaries of the input domain. For example, if my input field accept the value from 1 to 100, okay, if my input field from the wants the input to have from varies from 1 to 100, so I will apply my BVA will be from the boundary is 1 and 100, and that is minimum value, maximum value, then min plus 1, max minus 1 and mid. So, these are the test cases formed if I have my range from min to max, right. So, it should be minimum, that is 1, minimum plus 1, that is 2, 50 is the mid value, max is 100 and max minus 1. So, this is the test cases if we have one input variable which have the range to 1 to 100. So, that is called as boundary value analysis. Now, when we talk about robustness testing, it says that yes, the error could happen at the boundaries, but beyond the boundaries also. So, it has included 2 plus cases, that is min minus 1 and max plus 1. So, beyond the boundary, we should check whether how my system is reacting. It should show me the error that yes, the boundary has surpassed, but it should not crash down. So, right. So, this is what we check in your robustness testing. Now, when we are checking about for boundary value analysis and robustness testing, we change the only one variable at a time, right? We change the boundaries of one variable at a time. That is, we assume single fault assumption theory where error could only be at one part. But in worst case testing, what we do, we surpass that single fault assumption theory, and we can say that there could be multiple boundary values of the variables. For example, if I have suppose two variables and I have suppose if I am doing the boundary value analysis, I will be using minimum and mid, maximum and mid, min plus 1, min minus 1, mid. So, these will be my test cases. So, what I am doing, this is called as single fault assumption theory, that I am introducing change in only one variables, and the next second variable is kept in the normal values. But in case of worst case testing, I will be formulating all the possible permutation combination for this, right. So, that is called as worst case testing. Let's see an example. Suppose I have an equation ax square plus bx plus c, and my program is telling me the roots of the equation, right. We have studied these in maths. And how do we find roots? With the help of this equation. If b square minus 4ac is greater than or equal to 0, the roots are real and we will generate the roots. If it is less than 0, it's called imaginary roots. If b square minus 4ac is equal to 0, that means both the roots are equal. And if the a is equal to 0, it means the roots are not quadratic. So, this is the general rule that we want that our output should be like. For that, we have generated our test cases. Now, this is my input and this is my expected output, right. So, if I say what I do, this is single fault assumption theory, I will bring the change only in one at a time, in one variable at a time. So, I have taken the maximum values ranges from 0 to 100, right. 0 to 100 is my range of the variable, 0 to 100. So, here for the value a, I have taken the minimum value, then min plus 1, mid value, max minus 1 and max. And these two are 50, 50, 50, right. Then for b also we have done the same thing, and for c also we have done the same thing. So, this is how I have prepared my inputs. Now, what should be the corresponding output? I have find out through this formula, and then I will execute this test cases, and I will find out whether the output that is given by the software is same as that of the expected output or not. So this is how we create test cases through boundary value analysis. Next is equivalence class testing. Now it says that we need to create various classes of errors, classes of input data. So here input data is partitioned or classes where the software is expected to behave similarly for the all values within a class. So what we are doing, we are suppose doing the partition on the basis of inputs, right? So we can have two first classes, that is valid input. So we will be having two classes, valid input and invalid input. So we will assume that if my program is working correctly for one set of valid input data, my program will work correctly for all sets of my valid inputs. If my software is working correctly for one set of my invalid input data, then I will assume that yes, it will work for all other invalid input data also. So this is assumption. So here we are identifying the equivalence class. We can do it by on the basis of input or in the basis of output. Input the basis we have done valid input or invalid output. Whereas if we are creating the equivalence class on the basis of output, we can form, for example, in this, we can have the classes, we can generate the test cases on the basis of if my roots are real, if my roots are equal, if my roots are imaginary, or if my roots are, the equations are not quadratic. So here I will be having 4 test cases if I make the equivalence class on the basis of my output. If I make my equivalence class on the basis of input, I will be having 2 test cases. So that is called as equivalence class partitioning. Next is your cause effect graphing technique, in which I have different causes and what will be the effect. It means these are my inputs and what effect or what output I will be creating, right? So we will identify the input and output, then I will draw a cause effect graph and then we transfer that graph into the decision table. So with the help, first I will create my inputs, these are my inputs, and what is the effect, and this will be my output. And with the help of this, I will be creating a decision table, and with this decision table, I will be generating the test cases. So for this, I will create 1 test case. For each of these, I will be creating 1 test case. So that is called as cause effect graphing technique. So this was your functional testing, in which we were testing the software as a black box, and we were not considered how that input is getting transformed to the output. We were not concerned about that. So other type of testing is called structural testing, where we are concerned about the internal designs and implementation of the software. It is mostly carried out by developers themselves. It validates the various parameters of the software based on its types. So here we have input and we are seeing how my input is getting transformed into the output. What path it is following, we are testing in that. It is also known as clear box testing or glass box testing. The different type of testings are control flow, data flow, slice based, and the mutations testing. In control flow testing, we check whether each of the control statements has been executed or not. So here we create control flow graph, and then we define the coverage target, and after that we form the test cases. So after the creation of test cases, we execute the test cases and analyze. So basically we check whether all the path is covered or not, where all the branches are covered or not, then all decisions, if else statements are covered or not, whether loops are covered or not, and whether all the error handling paths are covered or not. So basically we are testing that each of the code that we have written is being actually be executed or not. Next is your different type is your data flow testing, in which we are testing whether the variables that we have declared are been properly used or not, right? Then we have slice based testing, in which we create slices of the software and do the testing. Last one is mutation testing, in which we test the efficacy of our test cases that we have created. So example, we have a original program and we have a test cases, right? For that, then what we do, we create a small change in our original program and we call it as a mutant program. Then we execute our test cases on that mutant program, right? So if the output of both test cases for both 2 programs are same, it means my test cases are not efficient enough. Whereas if the test cases show me the different result, we called it as the that the test case is efficient. So that was your structural testing. So in structural testing, we basically test the structure of the project. Now, next topic is your next test stubs and drivers. So when we are testing the unit, independent units. Suppose I have my I am testing this test module independently. Now this module is not independent in entirety. It has been called by someone or it is calling someone. So when I am testing this unit independently, I need some dummy code, right? In the case of unit testing, I need some dummy code to call this, and so I will call that as driver routine. So driver routine is basically a dummy code that is being used to test a module in your unit testing. Whereas my this test case might be getting some information from some other module. So that is known as your stub. The stub will consist of your important code, important information that is passed to that module before getting it tested. So this is all we are going to discuss in this today's lecture. Thank you.